Hello everyone, welcome back to our channel. In today's video, we will be discussing about the least common multiple, or we call it least common denominator. So, this is a prerequisite for you to add, subtract fractions, especially with different denominators, or we call it dissimilar fractions, as well as adding and subtracting polynomials, rational expressions. Okay, most especially if the denominators are not the same. Okay, so I hope that you are going to enjoy this video. So, let's get started. Least common multiple, or we call it least common denominator. Okay. So what is LCD, or least common denominator? Now the lowest or smallest common multiple of the denominators of fractions are called as the least common denominator. It is also termed as LCD, or least common denominator. It is used in the simplification of addition, subtraction of fractions. Now let's proceed to the product. So the answer to a multiplication problem is called a product. For example, 6 times 6 is 36. Okay? And 7 times 8 is 56. And 8 times 9 is 72. Okay. What about multiple? Okay, when we say multiple, the product of a whole number multiplied times any other whole number. So that is the definition. Call it multiple. Then some multiples of 6. We have some multiples of 6. We have 6, 12, 18, 24, 30, 36, and 42. If you are asked to name some multiples of 5, we have 5, 10, 15, 20, 25, 30, and 35. How about for multiples of 7? We have 7, 14, 21, 28, 35, 42, and 49. How about if you are asked to name some multiples of 4? So we have here 4, 8, 12, 16, 20, 24, and 28. Okay, meaning to say these numbers are exactly divisible by 4. How about multiples of 9? So we have 9, 18, 27, 36, 45, 54, and 63. Now how about common multiple? When we say common multiple, this refers to a number that is a multiple of 2 or more numbers. For example, if you're asked to find some multiples of 3 and 6, meaning both these numbers these numbers can be divided exactly by both these numbers, particularly 3 and 6. We have 6, 12, 18, 24, 30, 36, and 42. So these numbers or set of numbers are actually the multiples or common multiples of 3 and 6. So what are some common multiples for 2 and 8? So we have here 8, 16, 24, 32, 40, 48, and 56. It means to say that this set of numbers are exactly divisible by 2 and 8. So they are common multiples of both 2 and 8. How about common multiples of 4 and 6? Okay, so this we have 12, 24, 36, 48, 56, and 60. Again, this set of numbers are exactly divisible by both 4 and 6. What about common multiples of 3 and 7? So we have 21, 42, and 63. So we can divide these numbers exactly by both 3 and 7. How about 5 and 10? So common multiples for 5 and 10, we have 10, 20, 30, 40, 50, and 60. This set of numbers can exactly be divided by 5 and 10. Both 5 and 10. So, we're done giving examples about the common multiples. Now, we are going to focus now our attention with the least common multiple. Now, least common multiple refers to the smallest common multiple of a set of two or more numbers. So, for example, we have here 5 and 6. So, the multiples of 5, we have 5, 10, 15, 20, 25, and 30, and so on. Multiples of 6, we have 6, 12, 18, 24, 30, 36, meaning you just add 5 from 5, then add another 5 from here, okay, and so on. So, you've noticed that the least common multiple, this is the first common multiple between 5 and 6, therefore this is what we call the least common multiple, which is 30. Now, what about the least common multiple of 3 and 8? So, using the listing method again, we have here 3, 6, 9, 12, 15, 21, 24. These are multiples of 3. The multiples of 8, you have 8, 16, 24, 32, 40, and 48. Now, we are going to look at the least common multiple. So, the first multiple that is common to both 3 and 8, which is 24. What is the least common multiple of 4 and 8? So, we have here for 4, multiples of 4, 4, 8, 12, 16, 20, 24. And for 8, we have 8, 16, 24, 32, 40, 48. Okay, take note that you are going to first write the first number itself. So, you have your 8. So, this is now the least common multiple between 4 and 8 is 8. Okay, next. How about 6 and 8? So, for 6, the multiples of 6, we have 6, 12, 18, 24, 30, 36. And for 8, you have 8, 16, 24, 32, 40, and 48. So, the least common multiple, as you've noticed, using the listing method, we have here 24. Now, what is the least common multiple between 4 and 10? So, we are going to use the same strategy, listing method, 4, 8, 12, 16, 20, 24. And then for 10, we have 10, 20, 30, 40, and 50. Now, looking at the least common multiple, we have 20. What about between 3 and 9? So, we have here 3, 6, 9, 12, 15, 21. There's our multiples of 3. Multiples of 9, we have 9, 18, 27, 36, 45, and 54. So, the least common multiple between 3 and 9 is 9. Okay. Now, to add or subtract fractions with unlike denominators, we need to find the multiples of each denominator or the least common denominator. So, this is our denominator, 1/5, the denominator is 5. Now, compare the list of multiples and circle the common multiples between the two lists. Okay? So, for 5, this is the denominator. We have here list the multiples of 5. We have 5, 10, 15, 20, 25, 30. And for 10, we have 10, 20, 30, 40, and 50. And we now circle the common multiples. These are the common multiples. We have here 10. We have 20. We also have 30. But the least common multiple is 10. Okay. So, use the lowest common multiple as the denominator. Therefore, our lowest common multiple will be 10. Okay. So, this number is also called the least common denominator. Now, let's proceed to another example. Find the least common denominator or least common multiple between 2 and 8. So, for instance, we are adding 1/2 and 1/8. So, the denominator of 1/2 is 2. So, the multiples are 2, 4, 6, 8, 10, and 12. The multiples of 8 are 8, 16, 24, 32, and 40. Because 8 here is the denominator of 1/8, the second fraction. Then, for 1/10, so here, our least common multiple is 8. And the next, 1/10 and 1/8. So again, 1/10, 10 is the denominator here. List down all the multiples. We have 10, 20, 30, 40. And 4 is 1/8. So the multiples of 8, we have 8, 16, 24, 32, and 40. So the least common multiple is 8. Next, how about 1 over 10 and 1/4? So we have the multiples of 10, 10, 20, 30, 40. For 1/4, 4, 8, 12, 16, 20. Okay, so the least common multiple is 20. For 1 over 10 and 1/4, the LCD is 20, or least common multiple. Okay, next. For 1/2 plus 1/4, we have this different denominators again. So for denominator 2, the multiples are 2, 4, 6, 8, and 10. For 4, denominator 4, the multiples are 4, 8, 12, 16, and 20. And the least common multiple or least common denominator is 4. Okay, next. 1/2 and 1 over 12. The denominator 2, we have the multiples 2, 4, 6, 8, 10, 12. And for the multiples of the denominator 12, we have 12, 24, 36, 48. So the least common denominator is 12. Next pair of dissimilar fractions are 1/3 and 1/5. Alright. We have the denominator 3, the multiples are 3, 6, 9, 12, 15. And for the denominator 9, we have 9, 18, 27, 36, 45. Now the least common multiple or least common denominator will be 9. Okay. Now there's a shortcut for finding the least common denominator or least common multiple. We need to check to see if the smaller denominator divides evenly into the larger denominator. If it does, use the larger denominator for your LCD or LCM. Okay, for example, you have 1/3 plus 1 over 9. So the shortcut way is look at the larger denominator. Between 3 and 9, 9 is larger. Then try to divide 9 divided by 3. It says here that if the smaller denominator divides evenly into the larger denominator, then use the larger denominator for your LCD or LCM. Since 3 will divide evenly into 9, so 9 is your LCD or LCM. You don't need to list down the list of multiples, okay? You don't need to do that because this is the shortcut way. Since it's the bigger denominator, if 9 is exactly divisible by 3, then automatically 9 is your LCD or LCM. Next. 1/2 and 1/4. Okay, using the shortcut, what will be the LCD or LCM? So we have here 1/2 and 1/4. 4 is larger, the larger denominator, and 4 is exactly divisible by 2. Since 2 will divide evenly into 4, so 4 is your LCD or LCM. Okay, next. 1/2 plus 1 over 10. Okay, using the shortcut, 2 will divide evenly into 10. Because 10 divided by 2, that gives us exactly 5. So 10 is our LCD or LCM. Okay. How about 1/2 or 1 over 2? Or 1 over 12? Okay. Since 2 will divide evenly into 12, so 12 is your LCD or LCM. Because 12 divided by 2 is exactly 6. Okay. Next, 1/4 and 1/8. Since 4 will divide evenly into 8, or we have 4 divided by 8 divided by 4 is exactly 2, or we call it 4 will divide evenly into 8, so 8 is your LCD or LCM. The bigger denominator is the LCD or LCM when the bigger denominator is exactly divisible by the smaller denominator. Okay, 1/3 and 1/6. Using the shortcut, 3 will divide evenly into 6. So 6 is your LCD or LCM. So 1/3 and 1 over 12. Okay, 12 divided by 3, that is exactly equal to 4. Therefore, 12 is our LCD or LCM. Okay, 1/3 plus 1/15 or 1 over 15. Since 3 will divide evenly into 15, then our LCD is, or LCM is 15. Next, 1/3 plus 1/8. Okay, so 3 will not divide evenly. So by this example, okay, by this example, since 3 will not divide evenly into 8, so 8 divided by 3, that is 2 point something, maybe 2.6 or 2.67, something like that. Okay, since 3 will not divide evenly into 8, so find the least common multiple. So the least common multiple, you're going to do the listing method, or later on I will introduce to you the prime factorization method. So the LCD between 3 and 8 is 24. Because you could no longer use the shortcut because 8 is not exactly divisible by 3. Now, there are two methods for getting the least common multiple. So the one that we had a while ago, we call it listing method. Name the first 6 multiples of 6. Okay, so you know this already. You have 6, 12, 18, 24, 30, 36. Name the first 6 multiples of 5. So you know how to get the multiples of 5. You have 5, 10, 15, 20, 25, 30. Then now for the common multiple, the same as was what we discussed a while ago. We just repeat this one for the sake of trying to compare it to the other method. So a common multiple is a number that is multiple of 2 numbers. So our common multiples, 4 numbers, 4 and 10, 20 and 20, and this is also the least. So again, the least common multiple is the smallest number that a set of given numbers divides evenly into. It is useful to know how to do this so you can find a common denominator when adding or subtracting fractions. And there are 2 ways to find the LCM. The least common multiple method number 1, to find the LCM of 2 numbers, first is list the multiples of both numbers. Then find the least multiple that both numbers have in common. So for the least common multiple method number 1, make a list of multiples, or we call it listing method. So find the LCM of 10 and 12. So for 10, we have our 10, 20, 30, 40, 50, 60, 70, and so on. So we have our 70, 80, 90, 100. For 12, using the listing method, we have 12, 24, 36, 48, 60. You stop at 60 because you've noticed you also have 60 for the multiples of 10. Therefore, the LCM, or the least common multiple, is 60. So how about finding the LCM of 32 and 40? So for 32, we have here 32, 64, 96, 128, 160, 192, 224, 256. For 40, the multiples are 40, 80, 120, 160. Then we stop at 160 because we've noticed that we have 160 as of our multiples of 32. So the least common multiple between 32 and 40 is 160. Now, what is the least common multiple of 6 and 8? Okay, so listing down the multiples of 6, we have 6, 12, 18, 24, 30, 36. And 8, we have 8, 16, 24, 32, 40, and 48. So the least common multiple is 24. How about least common multiple of 3 and 9? So we have for 3, 3, 6, 9, 12, 15, 21. Then 9, 9, 18, 27, 36, 45, and 54. So the least common multiple is 9. So method 1, what have you noticed for method 1? It's very easy to do. All you have to do is list down all the multiples. So method 1 is a good method if both of your numbers are really small, or if you're dealing with small values. So what if you have really large numbers? So it might take too long to keep listing multiples until you find a common multiple. So here is method number 2. So if we're dealing with large numbers, we have to use method number 2, or it's easier for us to use method number 2. So least common multiple method number 2, this is now the process. Write, or the steps. Write the prime factorization of each number. Then select all common factors at once. Then next would be select the remaining factors and multiply. Okay, so we have here prime numbers, prime factorization. From the word prime, meaning we are going to factor the numbers into prime numbers. So what are prime numbers, by the way? So in your junior high, if prime number is a natural number greater than 1 that is not a product of two smaller natural numbers. Okay? So a natural number greater than 1 that is not prime is called a composite number. So it's opposite to the composite. So a prime number is only has exactly two factors, 1 and itself. Okay, so let's start with an example. The least common multiple method number 2 between 18 and 20. So 18 is the prime number, prime factor of 18. Let's start with 2. 2 times 9. The 9 can be factored with prime factors. We have 3 times 3. So you have here 2 times 3 times 3. So this is now the prime factors or prime factorization of 18. Then we are going to factor out 20 into prime numbers. So we have 2. Again, 2 is the smallest prime number. So we have 2 times 10. So encircle 2 because 2 is already a prime number. Then 10 is divisible or have factors, prime factors of 2 and 5. So these are now prime factors. So this is prime factorization method. Sometimes we call it factor tree. Okay? So you have to write all the prime factors, 2 times 3 times 3, and here is 2 times 2 times 5. Select all common factors 1. So 2 and 2. So these are common factors. Okay, it's a pair of 2. So you just write here 2 once. Then for 3, there's no common factors for 3 here. So you write all. So 3 times 3. Then another 2 here times 2. Then times 5. So the only common factor, the only common prime factor of both 18 and 20 is 2. Then you write it here and then all the rest will be copied. 3 times 3 times 2 times 5. So the least common multiple between 18 and 20 is 180. Okay? So it will take time for us to use the listing method if we're going to do the listing method. So this is now how you're going to use prime factorization in getting the least common multiple. Okay, let's proceed to another example. How about 45 and 72? If you are asked to get the least common multiple or LCD, if we're dealing with dissimilar fractions, 45 and 72, you have 45. You think of prime numbers that can, that is a factor of 45. So you have here 5. So 5 times 9. And 9 can be factored out with prime numbers 3 and 3. So we have now, arranging it from smallest to greatest prime factors, you have 3 times 3 times 5. Here, we have 72. Okay? Actually, you can factor it out even if you're going to factor it out with composite numbers first, composite factors, then later on until you are going to come up with the final prime factors. So every prime factors you are going to encircle. So 8 times 9, then 8 is factorable. We have 2 times 4, and 4 can be factored out by prime factors 2 times 2. And for 9, you have here the prime factors are 3 times 3. Then less down all the prime factors, you have 2 times 2 times 2, then times 3 times 3. Okay, select all common factors. The common factors, and write it once, are only 3 times 3. The same here, 3 times 3. So write that once. So that's 3 times 3. The one that we underlined, we are going to write that once. So that is a pair. You have 1 3 here, you also have 1 3 here, another 3, another 3. So you have to write 3 times 3. Then list down the remaining factors that are not common. So times 5 times 2 times 2 times 2. So the least common multiple between 45 and 72 is 360. Okay, next. So same method, we do it prime factorization method, but we can also use the ladder way of presenting it. Sometimes we call it ladder method, but still under the method number 2, it is prime factorization because we still use the prime factors. So this is another way of solving or getting the LCM or finding the LCM. So finding the LCM, least common multiple between 48 and 80. So using the ladder method, you are going to write 48, then 80. Then put this bar, or what do you call this one? So 48. So think of a prime number that can divide both 48 and 80. And the smallest prime number is 2. But not all the time that the given set of numbers are divisible by 2. It could be divided by the next prime number, which is 3. So since 48 and 80 are both divisible by a prime factor 2, we'll divide it 2. So you are going to write it 2 here. Then 48 divided by 2, that is 24. 80 divided by 2, we have here 40. Then now we have here 24. 24 and 40. So think of another prime number that can divide both 24. Exactly divide both 24 and 40. Still divisible by a prime factor 2. So 24 divided by 2 is 12. Then 40 divided by 2 is 20. Then another 12. What is a prime number that is exactly divisible by that can divide evenly by what particular prime number that can divide both evenly? 12 and 20. Okay, 12. So still divisible by a prime factor or prime number 2. So 12 divided by 2 is 6. 20 divided by 2 is 10. Next, now we have 6 and 10. So any number or prime number that can divide both 6 and 10. Still, they are factorable by a prime number that can be divided by a prime number, which is 2. So 6 divided by 2 is 3. 10 divided by 2 is 5. Now, the one that we put here are already common factors. That's why we are going to write these ones. It is just the same as prime factorization, but here we can easily see what are the common factors. Okay? Now, these are the non-common factors. So 6 divided by 2 is already 3. 10 divided by 2 is 5. And 3 and 5 are already prime factors. So we're going to list down or write down our least common multiple. We have 2 times 2 times 2 times 2. So we have it here. Then copy here times 3 times 5. And we're going to get the product. The least common multiple is 240. Okay? So again, this is what we call the ladder method because it looks like a ladder. Look at that. Okay. So it's up to you which one you're going to use. Is it this way, using the factor tree, or the ladder method? But again, this is method number 2 under prime factorization. Okay. Now, let's proceed to another example. What about for using prime factorization method number 2? List the prime factorization to find the least common multiple between 18 and 20. Okay, for a moment, I think we're done with that. 18 and 20. Okay. So we're done with this. So now it's your turn to try finding the LCM of 15 and 10. Find LCM of 21 and 14. Find the LCM of 60 and 70. And I want you to use all the 2 methods, the listing method and prime factorization method. But under the prime factorization method, I want you to use both factor tree and the ladder method. Okay? So only 3 numbers to explore on getting the LCM or LCD on using different methods. Okay. Now, since you know already how to get the LCM or LCD, now how about if we're dealing with monomials and polynomials? Now, to look for LCM of monomials and polynomials, it's just the same. Again, the LCM is least common multiple. So, for example, find the LCM of 3x squared y squared and 4x to the power of 5 y to the power of 4. The first step is list multiples factors of each coefficient. We call it coefficient. Okay? These are numerical coefficient 3 and 4. So, you have here 3 and 4. So, listing down the coefficients, by the way, you need to integrate which one you are going to use. You can use the listing method, you can use the prime factorization, you can use the ladder method, or you can just use the shortcut method. So between 3 and 4, using the shortcut, using the listing method, we have 3, 6, 9, 12, 15, 18, 21. 4, 8, 12, 16, 20, 24. And the least common multiple is 12. Okay. The next is find the first shared multiple. In this case, it is 12. Now, for the variables, okay, for the literal coefficient, we are going to get the largest exponent. So, the variables involves x and y's. For x, the largest exponent, here x squared, here x to the power of 5. The largest exponent is 5. Then y, the largest exponent for the variable y, since this is y squared and this is y to the 4th, so the largest exponent is 4. Therefore, our least common multiple is 12, then x to the power of 5, y to the power of 4. Okay? Again, we are going to get the LCM of the numerical coefficient or the numbers, and we are going to list down the variables and use the highest exponent or the largest exponents. So that is how we are going to get the least common multiple for monomial. Now, how about this one? Okay. So, find the LCM of 15a squared b c cubed, 16b to the power of 5 c squared, and 20a cubed c to the power of 6. So, a while ago, the first one, you use the listing method. Now, this one, we are going to use the prime factorization method. So, if you have your 15a squared b c cubed, so factor the first monomial. So, 15 can be factored out. Prime factors are 3 and 5. So, 16, the prime factors are 2 to the power of 4. Or that is 2 times 2 times 2 times 2. Okay? And for 20, these are prime factors already because this is 2 raised to the power of 4. And this is 2 raised to the power of 2. For 20, we have 2 raised to the power of 2. That is 2 times 2 times 5. 5 is also a prime number. Then a cubed c to the power of 6. Now, to use each factor, the greatest number of times it appears. So, between 3, so we have here 3 times 5. So, we have here, there's no common. So, you have to write 3 times 5. There's no common factors for 3 here. So, just write 3. And for 5, this is common only for first and third monomial. Just copy 5. Then, for 2, the factor 2 here, what is the greatest exponent? You have here 4 and here is only 2. Therefore, we're going to use the exponent 4. So, you have 2 to the power of 4. Then, for a, what is the highest exponent? You have here 2. There's no a, variable a here. And here is cube. That's why you have to write a cube. Then, for b, here, the exponent of b in the first monomial is 1. Here, the exponent is 5. Here, there's no b. Therefore, you're going to write 5. b to the power of 5. Then, for the variable c, the exponent is 3. The exponent here is 2. The exponent here is 6. So, we're going to use 6. Okay. So, use each factor the greatest number of times it appears. So, you are going to finalize the least common multiple is 3 times 5, that is 15. And 2 to the power of 4 is 16 because 2 times 2 is 4, times 2 is 8, times 2 is 16. Then 15 times 16, that gives you 240. So our least common multiple is 240, a cubed, b to the power of 5, c to the power of 6. Okay, again, that's 240, a cubed, b to the power of 5, c to the power of 6. Then, another example. The least common multiple of 2 or more monomials is found in the same way as the LCM of 2 or more numbers. So, find the LCM of 18xy squared and 10y. So, we are going to factor out prime factors of 18. We have 2 times 3 squared. Why it is 3 squared? That is actually 2 times 3 times 3. But since 3 repeats as a factor, prime factor, we just put it 3 squared times x times y squared. 10, the factors, prime factors of 10 is 2 times 5, then times y. Then, we are going to look for the least common multiple, copy 2. Then, we have, because these are common, then 3 squared, copy 3 squared, then times 5, then times x, then times y squared, because y 2 is the highest exponent for y. And those not common factors, we have to write all. So multiply the greatest power of each prime factor. So 2 times 3 squared is 9. So 2 times 9 is 18. 18 times 5 is 90. Copy xy squared. Therefore, the LCM of 18xy squared and 10y is 90xy squared. Okay, next. Another example. Find the least common multiple of 9xy squared and 15x squared y. So, if you have here prime factorization, 3 times 3, then times x times y times y. Okay? You can do like this, or you can actually just write y squared. 15 x squared y. So, you have prime factors of 15 is 3 times 5. Then, x squared is factorable, can be factored as x times x. Then, y. Or actually, you can write down all the values. Just write the variables as it is. So, xy squared and x squared y. So, common factors are circled and used only once in the LCM. So, the least common multiple, you have here 3 times x times y. Because this is common, you're going to write it once. So, you have 3 times x. This is also common. Then, times y, because this is common. But, then you have here 3 times 3 times 5. The all factors that are not common will be written as well. Times x times y. So, it's quite tiring compared to the previous one, because you list down individually all the variables. But you can actually just write down here x squared. So, instead of x times x, and y squared instead of y times y. So, you have here 3 times 3, 9 times 5 is 45. Then, we have here x squared, y squared. So, the answer, the least common multiple of 9xy squared and 15x squared y is 45x squared, y squared. Okay, next. How about finding the LCM of polynomial? So, of x cubed minus x squared minus 2x and x squared minus 4x plus 4. So, factor the first polynomial. This is a polynomial and this is also a polynomial. So, we have 2 polynomials. So, the same pattern. So, we are going to factor the first polynomial. The factors of x squared minus x cubed minus x squared minus 2x. You just extract x. So, you have here x times x plus 1 and x minus 2. Okay? Then, factor the first polynomial. The next factor, the second polynomial. X squared minus 4x plus 4, the factors is x minus 2. The factored form is x minus 2 quantity squared. Then, the LCM will be, copy here, x, then x plus 1, copy x plus 1. And since x minus 2 is common, but here the exponent is 1, considered as 1, the exponent here is 2, we're going to use the expression with use the highest degree. So, this is now the LCM. use each factor the greatest number of times it appears as a factor. So you have x times the quantity of x plus 1 times x minus 2 quantity squared. Okay, next, another example, finding the LCM. LCMs involving binomials are tricky. The binomial cannot be split into pieces. The binomial is a piece unto itself. Expand and observe occurrence. So if finding the LCM of x plus 1 times x minus 2 quantity squared and x plus 1 quantity cube or raised to the power of 3, so you are going to factor out this one. So you have x plus 1 and this is just the same as x plus minus 2 times x minus 2 because we have 2 as the exponent, meaning there are 2 factors of this binomial x minus 2. And x plus 3, it means to say that there are x plus 1 times x plus 1 times x plus 1. There are 3 binomials of factors x plus 1. So the most occurring x plus 1 is 3 times. Okay, here it's only once. It occurs once. Here it occurs 3 times. And the most occurring x minus 2 binomial is 2 times. So the LCM would be x plus 1 quantity cube or raised to the power of 3 times the quantity of x minus 2 raised to the power of 2. So this will be the LCM. Another example, if x minus 4 quantity squared and x minus 2 times x minus 4, the LCM would be, okay, this is the non-common factor. You write first x minus 2, and for x minus 4 is common to this one, but the highest occurrence is 2. So you will have x minus 4 raised to the power of 2. Next, x plus 1 raised to the power of 2 and x plus 5. So we have here the non-common factor is x plus 5. Then the highest exponent, since they are not common at all, there are no common factors at all, you just write it all. So x plus 5 times the quantity of x plus 1 raised to the power of 2. Okay? Now, I hope that you understand our lesson. This time, you are going to answer comprehension check. So, find the LCM of each. Number 1, 10, 3. Number 2, 14, 6. Number 3, 15, 6. Number 4, 15, 20. Number 5, 27, 18. Number 6, 4, 10. Number 7, 24, 32. Number 8, 20, 30. Number 9, 24, 36. Number 10, 35, 25. Number 11, xy squared, 15y cubed. Number 12, 20x cubed, 16x to the power of 4. Number 13, 18, 6v. 14, 3x squared, 10. 15, 20y, 14y squared. 16, 25x squared, 25y. 17, 32u squared, 14v squared. 18, 18m squared, 24nm. 19, 16x squared y, 32x. 20, 32ab cubed and 20ab cubed. 21, 30, 25, 10. 22, 28, 14, 21. And number 23, 10, 4, 18. Number 24, 10BA, 20BA, 28BA. 25, 8y squared, 16xy, 16y. And 26, 28b squared, 20ab cubed, 16b to the power of 4. Okay? So thank you so much for watching, and I hope that you really enjoyed and understand our topic. And to end this video, let's have a math code. Life is a math equation. In order to gain the most, you have to know how to convert negatives into positives. Okay, so God bless and take care everyone. Bye!